This is Regenerative Skills, the podcast helping you to learn the skills and solutions to create an abundant and connected future. I'm your host, Oliver Gaucher. New Society Publishers is your gateway to a regenerative future. They're not just about books, they're about transforming lives and communities through the power of knowledge and action. Their mission is simple: to inspire and empower individuals to create a more just, sustainable, and compassionate world. They envision a future where every person has the tools and resources they need to thrive in harmony with nature, where communities are resilient and interconnected, and where equity and justice are fundamental principles guiding our collective journey. If you subscribe right now to their newsletter at newsociety.com, you'll be the first to receive sneak peeks at new content and get discounts on upcoming title releases. You'll even get an exclusive discount code on your first purchase of books, ebooks, or audiobooks. So sign up today at newsociety.com. Hey everybody, and welcome back. So here we are in another summer of record heat, and in many places drought. Every year, more people around the world are waking up to the precariousness of their water situation as restrictions and bans are put in place while their municipalities struggle to hold on to their water resources. Now, as dire as this trend and predicament is, it can be relatively easy and low cost to save water just from the runoff from your roof. As water scarcity becomes ever more common, preparing for the next dry spell now can ensure that your home and possibly your garden as well can continue to thrive. In keeping with the theme of water regeneration this month, I spoke with Rob Avis, the co-author along with Michelle Avis of their book in the New Society Essentials series called Rainwater Harvesting. Now, Rob and Michelle founded Verge Permaculture, an award-winning design consulting and education company in Calgary, Alberta, after years of international training in renewable energy and regenerative design. Since its founding, Verge has helped more than 1,000 students and clients to design and create integrated systems for shelter, energy, water, waste, and food, all while supporting their local economy and regenerating the land. Through their design and consulting, they create havens that produce their own energy and food, harvest water, cycle nutrients, and restore the surrounding ecosystems, enabling property owners to thrive no matter what. Now, with such a broad range of knowledge, experience, and expertise, we focus mainly on rainwater harvesting techniques and systems in this episode as an entry into the larger concept of watershed regeneration and revival. In this session, Rob explains some of the key components of rainwater harvesting systems and the ways that you can treat and filter water for various uses. We talk at length about why expensive filters and disinfectants are often unnecessary, even for most potable water uses, and the different ways you can keep your stored rainwater clean. Rob also speaks about how rainwater harvesting systems fit into a larger system aimed towards water resilience in multiple living contexts from urban to rural applications. Now, I've been a fan of Verge Permaculture and all their great work for some time now, and I'm intending to create a larger series of in-depth talks with Rob and Michelle in the future. So if you enjoy this episode and have further questions that you'd like to hear us cover in future talks, then by all means send your questions and feedback to me at info@abundantedge.com or in the comments in the show notes on the website. I hope you get as much out of this talk as I did, so I'll turn things over now to Rob. Hey Rob, thanks so much for taking the time to be with me today. How are you doing?
Yeah, man, I'm doing great. Thanks for having me on the show.
Hey, it's my pleasure. Look, I've got a ton of questions for you about rainwater harvesting in particular and the book that you recently wrote for New Society Publishers. But before I get to all of that, let's start with what inspired you to work on rainwater harvesting systems as a part of a much larger strategy for security, resilience, and regeneration.
Yeah, great question. Well, I think that it all started off when we started going down the permaculture path, and we started recognizing that the world was a lot less black and white than it originally appeared. So Michelle and I both kind of cut our teeth in the oil and gas industry as pipeline engineers, and we were designing facilities and pipelines to bring natural gas and oil into cities so that humans could operate cars and buildings in the cold climate that is Canada and really North America and the world. And what we found there was this concept that humans require these resources, and this is the cultural myth that existed, and that there was really no alternative to the way that we are currently operating. And that was the cultural myth that was going on in Calgary at the time. And I started to kind of uncover things like peak oil and climate change and even little bits about soil erosion and, water depletion. And it really got us thinking that if this is the cultural myth and it's true, then we're hooped. And so luckily, I ended up getting a 3-minute video in my inbox, Greening the Desert, which most permaculturists have seen at this point, and called my wife up and said, we need to quit our jobs and travel and learn about this thing called permaculture and learn about renewable energy and see if there are other cultural narratives out there that allow humans to be just as positive as they are negative. And so we ended up spending about 6 months in Australia, 3 of which I lived on Jeff Lawton's farm, and we visited as many different permaculture operations down there as we could find. And they were all living on rainwater. And so another cultural myth that existed in our society was that rainwater starts as dirty, and at best it can be used for toilet flushing and subsurface irrigation, yet so much of the world relies on the annual fall of rainfall in order to survive. And so this really got us questioning why we have these cultural myths and narratives around both the energy, the water, the food. And we really started to question everything. And that was a bit of a ball of wax, because when we came back to Canada, all of a sudden we couldn't just operate in the way that we had been operating, because now we knew that there were other ways. And that really kind of thrust us onto our current journey.
Remarkable. Now, let's start from the beginning and talk about some of the ways that rainwater can be utilized in a home or even in a garden in a residential situation.
I mean, any way that you typically use what you would classify as potable grid-based water can be replaced by rainwater if it's harvested and managed correctly. And in a lot of cases, rainwater is a superior resource to grid-based water. And we could kind of get into all of the reasons why that is. But I mean, you can use it for drinking. You can use it for, washing your hands, showering, bathing. Hopefully, if you're harvesting rainwater, you recognize how dear it is and you're not flushing toilets with it. And then within the garden, any kind of irrigation works that you might have absolutely benefits from rainwater. The advantages of irrigating with rainwater is that it's very light on the mineral side of things. And so you're not going to plug up irrigation points with it, like drip irrigators. You're not going to salt the soils. And especially in the northern hemisphere, well, this is kind of an unknown fact, but 50% of our nitrogen comes in the form of rainwater through this really interesting interaction with lightning. So as lightning interacts with air and rain follows, it actually changes the chemical composition or the compound, the nitrogen compound in the air, to be a soluble nitrate, and then the rainwater will pick it up and bring it down to the ground. So rainwater actually ends up being a fertilizer as well as this wonderful hydration element.
All right. So in your professional opinion, now you alluded to this a second ago, is it usually necessary to install a disinfection and sterilization equipment in a rainwater harvesting or storage system?
So what I'll say is that depending on where your jurisdiction is, will depend on what your codes require you to do. And every jurisdiction is going to have a different take on what is and is not required. The other thing that I'm going to say to you, though, is that currently, and for the last 100+ years in Australia, over 3 million Australians drink rainwater without any end-of-line treatment. And the research that we uncovered as a result of writing the book that we're talking about right now showed that there are even slight statistical significant observations that showed that children that drank rainwater are actually marginally healthier than children that drank chlorinated grid-based water. So yes, when we're, I have to be, as an engineer, I have to be careful about telling people that they have to follow the code. However, we have a huge epidemiological case study that we can draw from, which is Australia, and even places like where you're calling in from today, where people are drinking rainwater successfully without we'll call it end-of-line treatment. Now, the other important thing to notice or recognize or acknowledge is that just because you don't have a UV filter or a particulate filter or a carbon filter on the back end of a rainwater system, it doesn't mean that there is not filtration and water quality improvement mechanisms occurring within a rainwater harvesting system, which I'll refer to as a treatment train.
Okay, well, let's explore that a little bit. Walk me through some of the options from the point of contact where rain first enters until the end point of use. That a rainwater harvesting system can clean the water without using expensive filters or disinfectant appliance.
So as part of this, I'll send you over an infographic that you can link in your show notes, which kind of has a visual representation of this treatment train. But I mean, the treatment train really starts right from the roof. And so a properly designed collection system is going to make sure that there's not a lot of vegetation hanging over top of it, that the roof is clean, and that it's generally going to be an impervious surface, which most roofs are, but not like an impervious surface without a lot of roughness, essentially. So water is free to flow over top of the roof, and the roof doesn't accumulate massive amounts of sediment or dirt on it. The water then flows through properly sloped gutters. And in a lot of the books, ironically, they talk about, the importance of keeping gutters clean. But some of the research has actually shown that gutters that have debris in them actually produce better rainwater because there's a biological cleaning mechanism going on in those gutters. Now, my recommendation is still to keep those gutters clean because we want efficient and effective conveyance. We don't want the water overflowing the gutters because we want to collect the resource. So we can find other ways to enhance those biological functions, which we're going to talk about here shortly. So the water moves through those gutters. Now, there's all sorts of products out there that put these screens on top of gutters to try and keep the debris out of the gutter itself and reduce maintenance. And it turns out that those are not really great solutions. One of the most important components in an effective treatment train and collection system is actually UV light. And so we want our roofs to have access to UV light. We want our gutters to have access to UV light. UV is the ultimate disinfectant. And when we put these screens over top of gutters, we end up removing that UV component from our gutters. And the other interesting that happens is that one of my contractors that I use up here, he's an exterior specialist, has removed more of these systems than he's put in, because he says it moves the problem 4 inches up. And so you end up getting this beautiful collection surface for organics, which can actually compromise the sheathing layer underneath the roof and causing all sorts of dry rot.
Yeah, I can imagine.
So we actually want to keep things transparent and open to the sun up there. So then once we collect it, we want to make sure that the water is then coming down a downspout. The downspouts typically vertical. If it's not, then it'll be at an angle. So we got to make sure we have the right slopes and things on there to make sure that we get good conveyance. And then we want to send all the water through something called a rain head or an inline filter. And this is a fine meshed filter. Typically, it's got a 45-degree angle on the mesh itself. And so any debris that collects on that filter is going to be automatically cleaned off. And I can send you a link to what one of these filters looks like so you can put it in the show notes. There's a bunch of products that come right out of Australia. They've kind of perfected this technology. And they're very inexpensive. They're about $50 to $60. And they fit right into your water harvesting system. Now, a lot of people in the rainwater sphere talk about the importance of first flush diverters. And it turns out that they're really not as important as everybody makes them out to be. If you're going to use one, there's a lot of controversy around how many liters or gallons you should be diverting from your stream. And basically, for folks who have never heard of this, a first flush diverter basically takes the first flush off the roof and basically diverts it away from the tank before it goes into the tank, and with the idea that this first flush is going to have the most debris in the water. And we'll talk about why it's not really all that important, but more often than not, I see first flush diverters that are not maintained, and so they get filled with debris, they plug off, and they go septic. And so they can end up kind of being more detrimental to the system than positive. But if you're going to use one, the rule of thumb is generally around 10 to 20 liters is the first kind of amount of volume that you want to divert. Anything more than that, and you get massive diminishing results. So you want to make sure that if you're going to put one in, that you're doing maintenance on a regular basis and cleaning the system out and making sure that it's functioning. If you're not the type of guy or person to want to do that kind of maintenance, then just avoid it altogether, and you can save the cost of that first flush diverter. The water then goes into the tank, and we send it into the tank into a pipe that depowers the flow of water. And we call this the quiet inlet. And we're doing this because we want to make sure that when the water goes into the tank, that it's not stirring up all sorts of sediment, that it's literally quietly being introduced into the existing water column. Now, there's a couple of reasons for this. It turns out, and the Romans, I'll just back up a second, the Romans were able to observe that water, when stored in storages, tanks, for long periods of time would improve in quality. They were able to observe that, but they weren't able to understand what was actually, or what the mechanism of that quality improvement actually was. And we now have the science to understand that mechanism, which is incredible. And this is probably the biggest insight from writing the book, was being able to dig into this research, because we had observed it as well in Australia, but no one could really tell us what the kind of scientific mechanism actually, or mechanisms actually was. And so this is one of the reasons that a well-designed system is so effective at filtering water. So number one, in a large rain tank where you have slow movement of water and long periods of time where that water is kind of sitting in that tank, you get sedimentation. And that sedimentation is going to form a sludge layer over time. Now, rainwater itself is actually very low in nutrient, and there are microbes that are picked up through the process of raining, through running over the roof and through the gutter and through the pipes. And so all those microbes that are in the water are super hungry because there's not a lot of food available. And so these microbes will end up, some of them will get dropped out in the sediment in that sludge layer in the bottom. And so as water slowly moves across that sludge layer, and as that sediment drops out, those microbes are super, super hungry, and they will grab onto anything that they can. And so when scientists in Australia did independent research and studies on this sludge layer, they found that when they looked at heavy metal concentrations as one example, that there were concentrations as high as 350,000 times that of the center water column in that sludge layer, which was a very strong indication that the sludge layer was actually acting as a bioremediation mechanism. And they tested a whole suite of heavy metals. They tested pathogens, bugs, microbes. And so it turns out that these sludge layers are actually held together with polysaccharides, which are essentially just complex sugars that are exuded by the microbes themselves. And those polysaccharides create this matrix that actually pulls and bioremediates that water. And the same mechanisms are actually going on the sides of the tanks as well, where the biofilms are forming. And so the tank itself is one of the most effective mechanisms for cleaning this rainwater. And you can see massive improvements in rainwater in as little as 2 weeks. So large storages create very effective bioremediation mechanisms themselves. And I'll just quickly go through the other two mechanisms. There's a series of other ones there, but the two main ones are going to be when you take water from that tank and you pressurize it, that instantaneous increase in pressure is going to destroy life, destroy some of the negative life. And then if you're running water into a hot water tank, there's actually a process called tyndallization, which moves water from one temperature to another temperature really rapidly. And so what goes on there is that as you have this aqueous solution, the rainwater tank itself, things like spores and microbes are in a non-dormant stage, because they're in an environment where they can kind of express themselves and be alive, as opposed to being dry and dormant. And so when you take a live organism like a spore and you change its pressure and then you change its temperature really quickly, you end up destroying it. And so all throughout this system, there are little mechanisms that improve the water from the rain cloud, basically, right to the faucet. And so those are the primary mechanisms that we see in the treatment train, essentially.
All that is fascinating. And I can't help, from a natural building perspective, wonder if you have any recommendations or observations on what type of roof you're using to catch the rainwater and how that might affect the water quality itself.
Yeah. So, I mean, from a natural building perspective, I don't know how much research is being done on thatched roofs and things like that, but generally speaking, we talk about materials that have fairly low roughness surfaces. So metal roofs are great. They do have a lot of embodied energy in them because they're metal, but they're fully recyclable and they last for really long periods of time. So we generally, tend to recommend those. And I'm a really big fan of standing seam roofs because the fasteners are not exposed. But I suspect clay roofs, in fact, I've read research on clay roofs and they can be like clay tiles can be really effective as well. Generally speaking, we want to avoid natural materials like cedar shakes. And so I suspect that thatched roofs would be similar to that. Cedar for sure can leach tannins and generally introduce all sorts of additional things that we're trying to avoid. I mean, we really want to keep the nutrient load inside of our rain tank low so that we can get that kind of those microbes working in our favor. We don't want to create or collect a soup of nutrients in that tank. It's one of the mechanisms that's occurring there is that, I'm trying to remember the scientific name for it, but the exclusion, I think, is what it's called. And so because the microbes are hungry, they really work hard for us.
Yeah, that makes a lot of sense. And that supports what I've heard around in the natural building community. For as many benefits as natural material roofs have, for one thing, I've never seen a gutter system on a thatch roof, and the preservatives that are naturally in cedar shakes in particular can have a toxic effect on water if you end up storing it. And I've really only had the most success from corrugated metal or other type of laminates. And I've also heard that asphalt tiles or asphalt shingles can also leach petroleum into your water storage tank over time.
Yeah, ironically, you can actually collect rainwater off of asphalt shingles. I think the big issue that you got to look for there are what they impregnate the asphalt with itself.
Sure.
It's funny, we asphalt itself is kind of a natural material, which is kind of a strange thing to say. It's the fungicides and the biocides that they put into it that can be problematic. The other big issue with asphalt is, again, it's a rough surface, and so it's going to accumulate more debris than a smooth surface. And then, of course, there are other problems with asphalt. I mean, at best, you're going to get a 10 to 30 year life cycle on that thing before you're creating an enormous amount of waste, and then you've got to replace it, versus a metal roof is really there for the life of the building as long as it's maintained properly. And I mean, there's going to be some exceptions to that, but yeah, I mean, metal's the best, I think.
I'm in favor of it too. It may not be an entirely natural material, but with its infinite recyclability, I think it makes up for it in a lot of other ways.
Absolutely.
Let's talk a little bit about the maintenance on a system like this. Do rainwater harvesting systems require quite a bit of attention, or is there a pretty big spectrum on the maintenance cycle depending on the system that you install?
A lot less than you probably think. So a properly sited and designed system needs to be inspected. So you should be going up and inspecting gutters and your roof and stick your head into the tank. But a very interesting misconception about actually getting into tanks and desludging and cleaning biofilms and things like that off of the walls. Ironically, when you add mains water, so chlorinated or sterilized, water that's sterilized with some sort of a sterilant in it, you end up killing or damaging the biofilms and the sludge layer, which detrimentally affects the quality of the tank. So we actually want to leave it alone. We it's kind of a bit of a loner, and it doesn't really want to be messed around with, because doing that will affect its ability to do what it does really best. So we want to look in there, make sure there's, no dead animals or anything like that inside the tank, or any, other kind of things that could potentially knock off the ecosystem. And so inspecting it once or twice a year is probably a good idea. Making sure all the pipes are functioning and not cracked or anything like that. And then if you are going to put any kind of end of line treatment, which you can do, there are some very simple filters that can make a difference and improve the overall water quality. Those would be other mechanisms or components of the system that you'd want to change on a semi-regular basis. And so those filters would typically be something like a carbon filter. If you want to be sure there's no SOCs or VOCs in the water, if you've got that kind of a load around you, which, let's be honest, everywhere on the planet has that floating around in the air now. And potentially a particulate filter as well, which you typically have a particulate filter before the pump, which wouldn't be super granular, but enough to protect the pump itself, the impeller. And then you might have a finer filter before it goes to your tap. And so, a 0.5 micron filter would kind of be something that we'd recommend. And you might have a pre-filter in front of that 0.5 micron filter. So just to kind of go through the train, you have a a pre-filter for the pump. Then you'd have a spun filter, like a 25 to 5 micron spun filter, which are very inexpensive and easy to change. And then you would go to something like a Dalton 0.5 micron ceramic filter, which is cleanable and lasts for very long periods of time. So it's not disposable, not for a very long period of time anyways. And then you might hit a carbon filter up just before it goes to your drinking tap. So I don't know if I'd carbon filter the entire house, but maybe the water that I consume, I might carbon filter, depending on what the kind of pollutant loads are around me.
Sure. And that's a very cautious system, but maybe required depending on the regulations where you install it, right?
Yeah. So in North America now, we've got the new CSA NSF rainwater harvesting code, which just came out just at the end of last year, the official code. And they're going to want a double barrier system. So something like I just described, plus they probably want a UV lamp as well. So they're being very, very cautious, or potentially an ultra filter, which will actually go below 0.5 micron. And what they're trying to do there is take out any viruses or harmful microbes. But in reality, when we look at the Australian case again, there have been no major outbreaks, in spite of the fact that 3 million people drink without any end-of-line treatment. 6 million people in Australia are actively using rainwater, and yet there have been no outbreaks. And what's really interesting about that number is that we cannot make the same claim about centralized water systems.
Yeah, that's incredible, and definitely shifts the perspective and some of the criticism on the things that we're putting in the mainline systems, especially disinfectants, chlorinators, and things like that, can actually do a lot more damage in some cases than the microbes that they're in there to protect against.
Totally. Well, I mean, chlorine plus organic matter in water creates chloroform, which is a known carcinogen. So when you look at the bias of Maine's water systems, their bias is managing short-term risk over long-term risk. So they'd rather give people cancer than have E. coli breakouts, basically.
Yeah. No, that makes sense from a liability perspective. It's a lot harder to look retroactively and be like, this is what caused the cancer, whereas the E. coli outbreak might be a lot more easy to identify and put blame on.
Mm-hmm.
Now, let's take a step back. It's probably something we should have talked about from the beginning, but walk me through some of the basics of sizing and calculating the needs for your own system and how much you could potentially harvest with roof size or the space that you have available.
All right. So starting with what's possible on your site, just a really simple formula for folks. If you take the area of your roof in square meters and you multiply it times the annual rainfall in millimeters, and I know not everybody uses millimeters, but we should move to metric as a society living in the 21st century. We end up with liters. So you can end up figuring out how many liters you have available to you in a year. And this is a really enlightening number for a lot of people. Enlightening in the sense that we typically have a lot less water than we're used to using. And so in Calgary, the typical Calgarian uses somewhere between 250 and 400 liters a day, which is just unbelievable. It's an enormous amount of water. And so that equates to, when I look at the rainwater resource and the typical house size in Calgary, in order to live entirely off of rainwater here, you'd pretty much have to move we'll go to the extreme, your 400 liters per day down to about 50 liters per person per day to kind of live within our rainwater budget. And so one of the hard parts about rainwater system design is that it's really difficult to optimize a system where rainfall is constantly changing. So year from year, you never know how much you're going to get. We've got long-term averages, but those long-term averages mean that there are tail events. So we've got really extreme years where, in 2013, we had twice the amount of rainfall that we typically get in a year in the first month of the spring. Whereas last year we had no rainfall at all. Literally, we had 0 millimeters of rain all year long.
That's remarkable. Yeah. And those types of variables must make it really difficult to figure out the calculations for this.
Absolutely. And so you need to build a risk matrix into the way that you do that calculation. Now, the other interesting thing is that, so you've got this fixed roof size, you've got a fairly consistent consumption rate, like you can predict that fairly consistently. And so you're trying to balance your collection surface with your consumption. But the thing is that because your consumption is consistent and your rainfall is not, you've got this kind of difficult, transient mathematical problem that you've got to solve. And that's where the tank comes in. So the tank basically acts as this intermediary buffer that allows us to consume water on a daily basis, which is what we need as humans, in spite of the fact that it only rains for a very small percentage of the year. And so the tank itself, especially in our climate, but pretty much in every climate, is usually the most expensive component in the system. In our climate, especially because we typically, if we want to use rain year round, we have to go below grade, and our frost line goes as deep as 8 feet here, even further when you go north, 12 to 15 feet sometimes, which means that your tank has to be below that level in the ground so that it doesn't freeze through the wintertime. We just put in a 5,000 gallon, 20,000 liter tank not that long ago for a client, and it was literally, $20,000. So, you do the math on that, and it's not inexpensive to have freeze protected water in this ecosystem. So we really have to make a lot of intelligent decisions, and we need a robust process that allows us to iterate between supply, demand, and storage. And so we spent a considerable amount of time in our book detailing that out. And one of the things that really irritated me when I got back from Australia and over the last decade is that as an engineer, I can use spreadsheets and I can run as many scenarios as I want. I'm very proficient with math. I'm very proficient with Excel. And so I can do those iterations and I can interpret and interpolate the data in order to come up with the best fit scenario. But trying to provide that to someone who's not proficient in Excel and not necessarily trained in the same way that I am is challenging. And so all of the books that I looked for over the last decade had no real good process for optimizing tank size. I even bought a $150 textbook from Wiley on rainwater harvesting. And to be honest, it was garbage. I mean, the book itself was garbage. And when it got to tank optimization, they had this breakout box on the book basically saying rainwater harvesting optimization, the optimization of rainwater harvesting tanks is something that engineering and architecture companies do, and they have proprietary algorithms to do it. And I was like, this is BS. So we actually spent about a month, Michelle and I, kind of taking all of my other spreadsheets and trying to distill down a process that anybody could follow so that they could find an optimized tank. And by optimize, what you're really trying to do in your rainwater harvesting system is minimize the tank size and maximize the utility. So how do you get the most amount of your system by making your system as small as possible? Because as we shrink the system down, we're able to shrink the cost down. And so you want to minimize the system without compromising. And you started this interview off with resilience. We don't want to compromise on the resilience. And so every person's going to have their own context with regards to what resilience means to them or what risks they're trying to mitigate. So we want to build that into that iterative process. And that's really important. And so one chapter in the book is actually dedicated, and we've actually delineated out how to build your own Excel spreadsheet to run this process. We've also built a professional, beautiful looking tool that you can download. I think it's $30. And so we've taken that whole chapter, which you can do for free if you want, but if you can't be bothered, we've built it into an Excel spreadsheet as well that has all of the rainfall data for the US and Canada. And then you can put other rainfall data into it as well if you're in a different country. And it takes you through stepwise to get to that resilient, minimized system.
Wow, that's a phenomenal resource. Now, let's talk about how someone can prepare to go through the coding and regulatory process where they are. Like you said, there's only a certain amount of recommendations that you can make because these rules change quite significantly depending on where you go around the world or sometimes even within the same country. So how would someone in a city or a suburb perhaps get started researching what the local codes and permits allow for in their area as far as rainwater harvesting system?
Yeah. So, I mean, I guess the short answer is, I had a mentor at the beginning of my engineering career, and he said, you can get any answer within 3 phone calls. And so That's the simple answer. But depending on where you live in the world, you need to basically be able to figure out what your local municipality, state, province, federal government has stated about this resource. And there could be health concerns associated with rainwater because they're uninformed. There could be other kind of more opaque reasons why they're not allowing rainwater to be harvested. And, one of the ones that we're coming up against here in Canada is that there's all sorts of water regulations that exist between, like basically treaties that exist between the United States and Canada. And so there's a lot of concern that if the large adoption of rainwater harvesting occurs, that it's going to change river flow rates crossing the border, which is a little bit ridiculous because eventually all the water ends up in the sink anyways. All we're doing is just slowing it down. So you kind of have to get to the bottom of that. And the best way to do it is just to, if you've never dealt with codes or regulatory systems, start by calling your local municipality. And they will basically provide you with a chain of phone calls or conversations that you have to have in order to figure out who's the kind of code official that owns that code or those regulations. And from there, you can start to make some informed decisions about what you can and can't do in your local municipality. I think, this is my personal opinion, that when rainwater harvesting is not allowed, we rapidly enter into a sovereignty issue. And as water becomes the kind of predominant issue in the 21st century, which it's in the midst of doing right now, it's important that we are having these conversations with our regulatory authorities because, when you look at Australia developed the way that it did because they don't have a water resource. Like, you cannot live in that country, in large portions of that country, without rainwater. And it appears that we're moving into a similar paradigm in other parts of the world as well. And so the more people that call our regulatory authorities where rainwater is not necessarily legal, the more pressure that's placed upon them to start thinking about this as a form of sustainable development.
Yeah, it's interesting to see as we move forward and water scarcity and sovereignty becomes a larger issue that is more actively addressed by local municipalities all the way up to federal levels, what kind of reaction they're going to have by incentivizing or disincentivizing the public to take control of their own water resilience. And up until now, I've mostly seen a disincentivization by governing bodies to people who are trying to move off grid in all kinds of ways, not just become more resilient with their watershed.
Yeah, there's a lot of fear. I think it's the 11th monkey or something like that. That concept that these massive systems that we've created actually require users, and there'll be some kind of unspecified number of users that remove themselves from that system, and then the next person in line ends up being the reason that the whole system collapses. One example is toilet flushing. And so as we move to low flow toilets, our sewers are struggling to manage with the lower flow rates of water in them because they were all built at 0.5% slope. And so as you remove liquid, the solids increase in percentage and the system stops operating. So it's not even a matter of, like small little things like that have massive impacts on these grid-based systems. And so I think from the regulatory agents' perspective, they're very concerned about collapse of these grid-based systems, which are so necessary for humans to coexist in cities. I think the elephant in the room here, though, I just got an article that I was reading this morning, actually, before we hopped on this call, from the Post-Carbon Institute. The article is called "The Future is Rural." And I think the elephant in the room that very few people are wanting to talk about is that cities are not providing us with the sustainable future that we need to move to if we're going to continue to have humanity on the earth. I mean, basically what's in the balance right now is this is going to sound really dire, but human extinction is like, we're facing that. We're looking that in the face right now based on how we're currently operating on this planet. And a lot of the pro-urbanist people on the planet right now are looking at cities as ways of reducing the energy intensity of humanity. But cities can only operate with high energy density resources, which allows us to basically turn cities into organisms. And so if you think about plumbing, sewage, water, electricity, natural gas, I mean, these are basically the veins and arteries of a giant organism that just happens to be built up of humans. And those arteries require enormous hearts, pumps, in order to send those resources into the city and then extract them back out. If in fact, and I would argue there is no if, but a lot of people are arguing that these days, if in fact we do have a looming peak oil issue on the horizon, then as you start to move down the other side of that oil curve, and it really doesn't matter whether it's now or 50 years from now, these massive systems start to decompose. They no longer operate.
Yeah,
And
the
so,
maintenance on them is enormous as well, to say nothing of the operating costs, especially if fuel prices start to soar.
yeah, I mean, you cannot fix water mains at 8 feet underground without massive amounts of diesel fuel. So sovereignty becomes a big issue. And so that's kind of where this article is going. The future is rural. We need low energy, decentralized solutions that allow people to take responsibility for their own actions, which is fundamentally the basis of what Mollison was talking about when he wrote the design manual for permaculture.
Now, local water resilience, as we're talking about, is obviously a much larger concept than merely harvesting and storing rainwater. So what are some of the other essential changes in habits and understanding of water that you'd like to see developed around the world and embraced?
So we need to have a more holistic view of waste. One of the early experiments we did here on our site was we started harvesting our gray water from our showers and our washing machine. And because I'm a bit of a loudmouth, I got in trouble pretty quickly and got a court order with a cease and desist order for our gray water system. Again, like when we look at the embodied energy of bringing potable water to houses and removing the wastes away, it represents a massive amount. Up to 25 to 30% of the energy expenditure of a city is just invested in those two functions. And so the other kind of big elephant in the room is that 2030, 2033 is kind of what we're slating for peak phosphorus globally. Now, phosphorus is on the periodic table of elements, which means it's atomic and it's a base element, which means that it can be cycled indefinitely into the future with properly designed systems. So part of looking at water in a more holistic way means that we're finding ecological systems to cycle our nutrients, so collect our rainwater, cycle our nutrients, grow our food, and essentially like the ultimate metaphor to a permaculture system, large or small, is that of a pinball machine. So if we think of water as steel pinballs, our job as designers is to look at all of the water resources that we have access to, rain, gray, black, dark gray, stormwater, and figure out how to put paddles into the system to keep those balls in play as long as possible on our sites. And that's ultimately how we're going to ensure long-term resilience and sustainability and regeneration, which is really what we should be aiming for.
Absolutely. Now, I really look forward to exploring the larger concept of water resilience and regenerative water systems with you at a later time. But since we focus so much on rainwater harvesting, can you tell our listeners how they can get in touch with you directly and where they can go to buy the book?
So folks can connect with us at vergepermaculture.ca. And we've got a ton. I've been writing blogs there for the last 10 years. We've also got a YouTube channel with tons of free resources there. You can go to YouTube and search Verge Permaculture. And then New Society Publishers has access to our book, and we can provide you with a link to that in the show notes below. And it's available in both hard copy and e-copy. And if you do end up getting your copy, or if you don't, on the Verge Permaculture website, we actually have a rainwater harvesting toolkit with a ton of free resources, as well as all of the hundreds of research papers that go to support a lot of the claims or statements that we've made in this particular podcast.
Fantastic. And yeah, like you said, all of those will be on the show notes for this episode on the website at abundantedge.com. Rob, it's been such a pleasure talking to you. I really look forward to continuing to collaborate and for doing a follow-up on the larger nuances of resilient water systems, especially in the residential context.
Thanks so much, man. I really appreciated the conversation, and I look forward to future ones.
Marvelous. All right. You have a great rest of your day, and I'll be in touch again soon.
Great.
Now, before we wrap this up, just remember that these episodes are only the beginning of the learning resources, design and coaching services, in-person courses, and interactive community that are available through Regenerative Skills. The Discord server is our free community where you can connect with other like-minded listeners, exchange ideas, stories, tips, and resources, as well as interact with me directly and quite a few former guests from this show. Our Instagram account at regen_skills is the best place to see the projects that me and the team are working on, both for clients and collaborators, as well as on our own properties. I'll also be announcing the certification courses, workshops, and gatherings that we've got coming up later this year. If you're interested in getting dedicated support for your own project, you can now schedule a free planning session with one of our team members through the request form on our website. You can also find all the links, show notes, and past resources there at regenerativeskills.com. We truly believe that no matter your experience, your knowledge, abilities, resources, or background, you can be a powerful force for regeneration on this planet, and we're here to help you find your path. So as always, remember to keep taking those little steps every day towards a regenerative future, and I'll be right by your side along the way.